Today we're going to look at an easier way to multiply fractions. Yesterday we used the area model using the rectangles and multiplying by dividing into portions and finding a portion by portion. So today we will be on page 12 of our toolkits, and we're doing multiplying fractions. And this is lesson 226. 2.2.6. Okay, so we have Stephanie, who is working on a problem 3/5 times 6/7 and started to draw rectangles down here, just like what we did yesterday. And Stephanie looked over at Audrey's work and saw that Audrey was way ahead of her. How did you get so far ahead of me? So why aren't you drawing these rectangles for these problems? I remember a shortcut, Audrey said. Didn't you notice that when we drew the rectangles, we got the same thing as if we had multiplied the numerators and then multiplied the denominators? 3 times 6 is 18. Okay, so 3 times 6, you're going straight across right here, and 5 times 7 is 35. So she got 18/35, which was a lot faster. So checking Audrey's method using the rectangle model, okay, we have 3/5. So 3/5, we're obviously going to be using this part here, where we're taking 1, 2, 3/5. That's 3 rows out of 5, and then multiplying by 6/7. So 6/7 would be 1, 2, 3, 4, 5, 6, and then we look at our double shaded areas right here, and we have 18 out of the 35, which is double shaded. So when you look at that alternative, when you're just multiplying fractions straight across, it does make it look a little bit easier, actually a lot easier. So let's see if we can use Audrey's method and solve these other problems. Okay, so first one that we're going to look at is example number 1. We have 7/8, and we're going to multiply by 5/6. Okay, so going straight across, that would be the quicker method. 7 times 5, that's 35, and 8 times 6 is 48. So that gives us 35/48. Okay, example number 2. We have 2/13. We're going to multiply that by 4/5. Okay, so easy enough. We go straight across, and we have 2 times 4, which is 8, and 13 times 5, which is 65. Now we always look whenever we're multiplying these numbers to get a fractional answer to see if we can reduce this. We always reduce our fractions to make it simplified. Okay, so 8 and 65, they do not share a common factor, so we can't reduce that. All right, so the next one, problem number 3, we have 6/7 times 6/7. And going straight across, 6 times 6, 7 times 7 gives us 36/49. Again, no common factors. Factors of 49 would be 1 and 7 and 49, which doesn't help us a lot. So problem number 4, example 4, we have 3/5 multiplied by 5/6. So we could go straight across. Okay, going straight across, we have 3 times 5, which is 15, and then 5 times 6, which is 30. Okay, but 15/30, they both go into 5, so they can reduce, but actually they both have a greatest common factor of 15. So this reduces to 1/2. Now, there's a method that certain elementary school teachers teach, and they call it the butterfly method. And the butterfly method is basically looking diagonally to see if there's anything that we can reduce here. So we look this way, the 5 and the 5. Can we reduce those two numbers with a common factor? And we can reduce both of these to 1 because we can reduce them both by 5. Then we look this way. Can we reduce the 3 and the 6? Both of these are factorable by 3. So we divide this by 3, we get 1. We divide this by 3, we get 2. So what allows us to use that butterfly method? Okay, so the butterfly it allows us to reduce them crosswise like this, because you think, when I'm multiplying numbers straight across, 6 times 6 or 2 times 4, I can switch these and I can make it 4 times 2. I'm still going to get 8 because the commutative property says I can multiply in any order. I'm still going to get the same answer. So if this is 4 times 2, it's like 4/13 times 2/5. But in this case, it doesn't help because this doesn't reduce. So if I were to write this as 3/5 times 5/6, switch it over, multiply the 5, change the 5 and the 3, it would be 5 over 5 and 3 over 6. And we all know that 5 over 5 is 1. And then 3 over 6 is 1/2. So that's kind of the thinking behind the butterfly method is, well, if I can just switch places with the numerators or the denominators, why don't I just reduce them? Instead of reducing this to 1 and reducing this to 1/2, let me just reduce them where they are. And that's a diagonal. Okay, so that's what allows us to do the butterfly method. So now we have 1 times 1 and 1 times 2, which gives us the answer of 1/2. Okay, so that is the butterfly method, or I call it just cross-reducing or cross-simplifying. Some people call it cross-canceling. So either way. So let's move on to the next problem. We have the area model of multiplying mixed numbers 3.5 times 1.5. Okay, so in this case, unlike yesterday where we have one rectangle representing one whole, we have the rectangles just representing different portions of this mixed number. Okay, so we're finding the areas of each section of this set of rectangles. So this is example number 5. All right, so let's set this up. I have 3 1/2. And we're multiplying it by 1 1/2. So using the area model, let's go ahead and break this up into 2 parts. Okay, so the first part is going to be the whole number part. So we have 3 1/2. So this is going to represent 3, and this is going to represent 1/2. This part is going to represent 1 1/2. 1, and this is 1/2. Okay, kind of like the expanded method. 3 1/2, 1 1/2. We did expanded method when we did the distributive property. So what we're going to do is we're going to find the area of each of these, where this is a 3 by 1 unit rectangle. Okay, so what would be the area of the base and the height were 3 and 1? 3 times 1 is 3. So that's 3 square units. And then this one is 1/2 by 1, because remember this is a rectangle, so that's 1, and that's 1. So 1/2 by 1, this is a 1/2 square unit rectangle. Okay, now this one down here, 3 units by 1/2 unit. So 3 times 1/2, well, what is 3 times 1/2? When we're multiplying a fraction by a number, it's always helpful to make 2 fractions. So 3 times 1, 1 times 2, that gives us 3 halves. And then this rectangle would be 1/2 by 1/2. 1/2 times 1/2 is 1/4. Okay, so now we have all these different rectangles, 3, 1/2, 3/2, and 1/4. To find the area of these rectangles in total, we're going to add 3 plus 3/2 plus 1/2 plus 1/4. Okay, so now we're adding these numbers together. Since we have fractions involved, that means we're going to need common denominators. Okay, so the common denominator here, let's call this a 1. So we have 1, 2, 2, and 4. The common denominator is 4. So let's change 3 to a number over 4. How many fourths are in 3? There are 12. And then 3/2. Now all we're doing right now at this point is we're using our giant ones. So remember, this is a giant 1, so we can change 3/2 to fourths. So how many fourths is 3/2? Multiply by 2, multiply by 2. And for 1/2, we have 2/4. And for 1/4, we keep it the same because it does have the same denominator. Okay, so this gives us 12 plus 6 plus 2 plus 1, which is 21/4. This is the area of that rectangle, which means that's 3.5 times 1.5 is 21/4. So we could change it to a mixed number. Okay, so if we're changing this to a mixed number, 21/4, we can basically figure how many 4s are in 21. Okay, so 21/4 is basically a division problem. 4 goes into 21 5 times, and then we have 1 left over, that's 1/4. Okay, so this would be your numerator, and this would be your denominator. That's how you change a fraction to a mixed number. All right, so let's try another mixed number problem. So let's see if the method we used earlier, where we're just multiplying straight across, will be a little bit easier than using this rectangle model. All right, so let's work on this problem. We have 3 1/2 times 1 1/2, and see if we can get this answer by bypassing that whole rectangle model. So first thing we're going to do is we're going to just write these as fractions. Okay, so how do you write 3 1/2 as a fraction? Okay, in case you've never done that before, we always start with the denominator and we go clockwise. We multiply. 3 times 2 is 6. And we keep going to the next number, which is a 1, and we're going to add 1, giving us 7, and we put it over the 2. Okay, so this will give us 7/2, and then 1 1/2 do the same thing. 2 times 1 plus 1, that gives us 3/2. Okay, so our problem is 7/2 times 3/2. Now that we have two fractions, we can just now go straight across. Nice and easy. 7 times 3 is 21, and 2 times 2 is 4. So we have the same answer, 21. Oh, 2 times 2 is 4. Sorry about that. So same answer, 21/4, which we can change to 5 1/4. All right, and then let's try this one. Should be able to finish this on your own. We have 1 1/3, and we're going to multiply it by 2 1/2. Okay, and what you should have after working on this is we have 4/3 times 5/2, which equals 26ths, or as a mixed number, 3 1/3.